Starship Flight 11 has officially completed its final V2 mission, marking a major step forward in SpaceX's path to full reusability. The launch, separation, and landing all went exactly as planned, proving years of iteration are paying off. But many are asking, why end the V2 series now? What's next for Starship after this flawless flight? Let's dive right in. Elon Musk has never believed in slowing down when something works. He pushes harder. And Flight 11 was the perfect example of that mindset. This mission wasn't about proving Starship could reach orbit. SpaceX already knew that. This time, Musk wanted to find out how much punishment Starship could take before breaking. Inside SpaceX, engineers called it the limit test. The goal was not to achieve a clean flight, but to expose every weakness left in the design. Musk's order was straightforward. Push it to failure. Let's see what breaks first. The ship or our expectations. That explains why Flight 11 was fundamentally different. SpaceX deliberately removed heat tiles from high-stress sections, leaving exposed steel panels to face re-entry heat exceeding 1,500 degrees Celsius. The Raptor engines were run on new timing sequences, pushing them beyond previous safety margins. It wasn't carelessness. It was controlled chaos. SpaceX wasn't gambling with billions. It was buying priceless data. And that kind of data only comes from the edge of failure, not from simulations or perfect flights. The launch began with near perfection. All 33 Raptor engines on the Super Heavy booster ignited at once, generating 7,500 tons of thrust, shaking the Texas coastline. The vehicle lifted cleanly, without the violent oscillations seen in earlier flights. Engineers later confirmed the cleanest liftoff in Starship history. As the rocket climbed past max Q, the point of maximum aerodynamic stress, telemetry showed everything nominal. It was quiet confidence inside mission control. Even Musk reportedly said, "That's how it should feel." Then came the most complex part, hot staging. Instead of shutting down all booster engines before separation, SpaceX kept 3 Raptors burning while Starship's 6 upper stage engines ignited through an interstage adapter. It's one of the riskiest maneuvers in rocketry, overlapping combustion at supersonic speeds. But once again, SpaceX nailed it. A flash of flame surrounded both stages for a moment. Then, perfect separation. Starship was free. The booster began its boost-back burn using 13 engines, one more than usual, simulating a high-stress recovery scenario. The sky above the Gulf of Mexico glowed orange as the 2 massive vehicles danced their separate descents. Meanwhile, Starship's 6 upper engines roared to life, propelling it toward orbital speed, 26,000 kilometers per hour. Every camera feed showed stability, every sensor reading green. But this wasn't just a victory lap. Deep inside the vehicle, those missing tiles were doing their job, testing the limits of SpaceX's stainless steel design. And for Musk, that was the real moment of truth. Could the ship survive the Inferno, with bare steel facing atmospheric plasma? To most viewers, Flight 11 looked like another clean mission. But behind the scenes, it was a deliberate stress test, a technical trial wrapped inside a successful flight. SpaceX was collecting failure data, the most valuable kind in aerospace. 4 main systems were being pushed beyond design limits. Thermal protection. The missing tile experiment wasn't an accident. Engineers intentionally exposed certain areas to full re-entry heat to understand what would happen in a real tile loss scenario. The results were astonishing. The steel hull absorbed the heat better than predicted, suggesting Starship might survive partial damage without catastrophic failure. Engine endurance. All 6 Raptors not only completed their primary burn, but also reignited successfully, a critical milestone. In deep space missions, relight capability can mean the difference between success and loss. The data confirmed the engines can handle longer burns with greater stability. Structural integrity. With uneven heat exposure and high dynamic pressure, Starship's flaps had to compensate aggressively. The control system responded with millisecond precision, evidence that the flight software has matured beyond anything seen before. What once took manual override is now fully automated. Landing geometry and control. As Starship descended, it executed the belly flop maneuver with exceptional precision. The flaps adjusted at double the speed of earlier flights, allowing smoother aerodynamic control. The ship then flipped upright and performed its landing burn with near-surgical timing, from 3 engines down to 2, before splashdown in the Indian Ocean. Each maneuver was a data-gathering event, each success a validation of Musk's test-to-destruction philosophy. And when the booster completed its controlled hard landing, one thing was clear. SpaceX had intentionally rehearsed the future, a catch landing without actually using the tower. Now here's where the story takes a sharp turn. SpaceX publicly called this the final V2 mission, but the data, and some subtle choices, suggest something much bigger was going on. During re-entry, sensors detected a brief Raptor reignition that wasn't on the mission plan. Insiders later confirmed it was part of a new autonomous control test, a system designed to automatically stabilize the ship during uncontrolled descent. In simple terms, SpaceX quietly tested Starship Flight 3 flight software inside a V2 rocket. That small event means a lot. It suggests Starship is transitioning from manual, human-supervised systems to fully autonomous, AI-assisted control, essential for catching rockets mid-air using the Mechazilla tower. And it doesn't stop there. The thermal tests revealed that bare steel handled heat far better than expected. That discovery could lead to a radical design shift: fewer heat tiles, simpler manufacturing, and faster refurbishment. Every hour saved on ground turnaround brings Starship closer to its ultimate goal: launch, land, refuel, repeat, all in a single day. Even the booster's hard landing wasn't an accident. It was designed to simulate a tower catch-miss scenario, to see how the ship behaves under an incomplete recovery. This kind of data is critical to prevent billion-dollar mistakes once real catch attempts begin. In short, Flight 11 wasn't the end of the V2 era. It was the quiet debut of V3 technology. And that means one thing: the next flight won't just return to Earth, it'll come home. But beyond the engineering triumph, there's another layer few talk about. Some analysts suggest Musk orchestrated this mission as a signal to NASA, to competitors, even to governments. The message? Starship is no longer a prototype. It's a functioning system ready for operational missions, from lunar cargo to rapid Earth-to-Earth transport. If true, this changes everything. Because once SpaceX can land, refuel, and relaunch within hours, it doesn't just dominate spaceflight. It reshapes global logistics, defense, and even disaster response. What do you think? Was Flight 11 just another test, or Musk's quiet declaration that Starship is now unstoppable? Now that the dust has settled, the meaning of Flight 11 is becoming clear. For SpaceX, it marks the end of testing for survival and the beginning of engineering for reusability. In just 11 flights, they've achieved what took NASA and other agencies decades: a full-scale orbital-class rocket capable of controlled descent and stable reentry. The next logical step is Starship Flight 3, expected to feature upgraded Raptor engines, improved thermal systems, and the first attempted tower catch. According to internal timelines, the first V3 prototype is already in assembly at Starbase. If that mission succeeds, it will redefine aerospace economics. Imagine a rocket that can launch, land, refuel, and relaunch multiple times per week. That's not science fiction. It's logistics evolution. But beyond cost and speed, there's something deeper here. Flight 11 represents a shift in mindset. SpaceX is no longer proving that reusability is possible. They're refining it into a routine. And that's exactly how revolutions start, quietly, one iteration at a time. From a human perspective, this flight was a reminder of why Musk keeps pushing the limits. Every scorch mark on Starship's skin, every line of telemetry, every controlled failure, they're pieces of a larger puzzle. Each one brings us closer to a future where humanity isn't just visiting space, but living there. And if Flight 11 truly was the moment Musk pushed Starship to death, then the result proves one thing: it didn't die, it evolved. Because in SpaceX's world, failure isn't the opposite of success. It's the fuel that powers it. And this is exactly why Starship Flight 11 will be remembered as a turning point. It wasn't just another test. It proved SpaceX is finally ready for full reusability and precision recovery. Every risk, every experiment in this flight brought us one step closer to rockets that launch, land, and fly again within hours. What this means is simple. The future of space travel just became real, and it's happening faster than anyone expected. If you found value in this breakdown, like this video, share your thoughts in the comments, and subscribe to Space Hub, where we deliver clear, data-backed insights on the biggest breakthroughs in space technology. Don't forget to turn on notifications so you never miss the next mission update. This is Space Hub, your trusted window into the future of space exploration. Because after Flight 11, the next era has already begun.